Out in the cold, silent dark between the stars, humanity has a messenger, Voyager 1. It's the farthest thing we've ever sent from home, drifting through interstellar space. But in late 2023, its whispers stopped. The data stream turned to gibberish. NASA's controllers stared in disbelief. The spacecraft was alive, but its voice was lost. Losing Voyager would be like a part of humanity itself going dark. That a 1970s machine survived this long is a miracle of engineering. But the team refused to give up. They began the painstaking work to rescue their silent explorer. The fate of our farthest emissary hung in the balance. Deep inside Voyager's flight data subsystem, a single corrupted memory chip brought silence. The FDS is Voyager's short-term memory, gathering all data before sending it home. Without it, Voyager was blind and mute. Engineers faced a daunting task, repairing 50-year-old tech from 15 billion miles away. The corrupted chip scrambled data into nonsense. The team raced to find a workaround, determined to save their silent explorer. Voyager is our only probe in interstellar space. The data is priceless. The world watched and waited. Would Voyager's voice return? The solution was a stroke of genius. Unable to fix the broken chip, engineers decided to abandon it, redistributing the affected software code into healthy memory locations. It was like rewriting a damaged sentence in the margins of other pages. No single spot was big enough, so they split the code into pieces, carefully placing each one. The operation required incredible precision and coordination, with a 45-hour time lag for every command. In April 2024, they sent the first fix, a command to restore engineering data. 2 days later, Voyager spoke clearly again. The stream of data was back. The team could finally see the spacecraft's health, temperature, power, system status. But the mission wasn't fully saved. The science instruments were still silent. Over the next weeks, the team painstakingly moved the rest of the code. By June 2024, all 4 science instruments were sending back precious information from interstellar space. The daring rescue was a complete success, a testament to human ingenuity. A small team had reached across an impossible distance to repair a machine from another era. Voyager was back. Its journey into the great unknown could continue. The world celebrated a triumph of perseverance and creativity. The mission was saved, but new challenges awaited. The fight to keep Voyager alive was far from over. The next battle time itself. Even with its mind restored, Voyager faces a relentless enemy time. The probes aren't powered by solar panels. The sun is just a distant star. Their energy comes from the slow decay of plutonium in their RTGs. Every year, their power dwindles by about 4 watts, a slow, inevitable decline. Engineers must make heartbreaking decisions about which instruments to shut down forever. It's cosmic triage. Which discovery is worth sacrificing for a few more months of life? In 2024, Voyager 2's plasma science instrument was turned off. More shutdowns are planned. Each shutdown saves a tiny amount of power, but permanently blinds the probe in one direction. The power margins are razor thin, less than a single watt of surplus energy. Even a tiny, unexpected power draw can trigger a crisis. In October 2024, Voyager 1's heater triggered a safety protocol, causing a temporary blackout. Every decision is critical. Every watt is precious. The goal: keep at least one science instrument operating until around 2030. The team devises clever ways to conserve energy, turning off heaters, harnessing power from other systems. It's a constant battle against entropy, a fight to keep our connection to the interstellar medium alive. The Voyagers are growing older and weaker, but their journey is more important than ever. Each day of data is a victory. The mission's end is inevitable, but the legacy will endure. The race against the dying of the light continues. Humanity's reach into the stars persists for now. Why fight so hard to save these aging explorers? Because the Voyagers are true pioneers, traveling through a region of space where humanity has never been. In 2012, Voyager 1 crossed into interstellar space. Voyager 2 followed in 2018. They're the only spacecraft to directly sample the stuff between the stars. The probes are rewriting our textbooks in real time. The Voyagers are our robotic proxies, sent to the farthest shore. The final frontier is not the end. It's the beginning. And the story continues. Before reaching the stars, the Voyagers transformed our understanding of the solar system. Their grand tour of the outer planets was a journey of revolutionary discoveries. In 1979, Voyager 1 found active volcanoes on Jupiter's moon Io, the first seen beyond Earth. Suddenly, the moons of the outer planets were alive, not just dead rocks. Data from Europa hinted at a vast liquid water ocean beneath its icy shell. Saturn's moon Enceladus offered the same tantalizing possibility. Where there's water, there could be life. These hints inspired new missions, like the Europa Clipper. Voyager revealed Saturn's rings in stunning detail, discovered Jupiter's faint rings, and found that Uranus and Neptune had rings too. At Neptune, Voyager 2 discovered the Great Dark Spot, a colossal storm with the fastest winds in the solar system. Even at the edge, wonders continued. In 1989, Voyager 2 saw ice geysers erupting from Neptune's moon Triton. From volcanic fire to icy plumes, Voyager showed our solar system is dynamic, violent, and beautiful. It shattered the old static model of the planets. The mission painted a new picture, a place far stranger and more wonderful than we ever dreamed. Each discovery opened new questions and new frontiers. Voyager's legacy is a universe of surprises. Its journey changed how we see our cosmic neighborhood. The adventure continues with every new revelation. The unknown is more exciting than ever. Communicating with Voyager is an engineering marvel. Voyager 1 is over 15 billion miles away, its transmitter as weak as a refrigerator light bulb. By the time its signal reaches Earth, it's less than a billionth of a watt. Catching that whisper requires the Deep Space Network, giant radio dishes in California, Spain, and Australia. As Earth rotates, one station always keeps Voyager in sight. These dishes are among the most sensitive receivers ever built, filtering Voyager's faint signal from cosmic noise. The vast distance means a round-trip conversation takes nearly 2 days. Every command is meticulously planned. A single mistake could be catastrophic. The Voyager team has become masters of ingenuity, finding ways to keep the mission going against all odds. In 2017, when the primary thrusters degraded, they fired up backup thrusters dormant for 37 years. They worked perfectly. This creative problem-solving keeps the whispers coming. Each message is a triumph of engineering and patience. The connection is fragile, but it endures. Voyager's voice, though faint, still reaches us. And with it, the story continues. Of all Voyager's images, one stands apart, the pale blue dot. In 1990, at Carl Sagan's request, Voyager 1 turned its camera back toward Earth from nearly 4 billion miles away. Earth appeared as a single pixel, a tiny point of light suspended in a sunbeam. Sagan called it the pale blue dot, a profound and humbling photograph. That dot is our home. Everyone you've ever known, every story, every life. The image reminds us of our place in the cosmos and our responsibility to cherish our fragile world. After this photo, Voyager's cameras were switched off forever to save power. The mission shifted from photography to interstellar exploration. The pale blue dot became a symbol of perspective and environmental awareness. It forces us to confront our significance in the vast universe. Voyager's journey gave us wonders, but also this humbling portrait of ourselves. Only a journey of this magnitude could provide such perspective. The legacy of that image endures. It's a message not about other worlds, but about our own. Voyager's greatest gift may be the way it changed how we see ourselves. The Voyager mission is more than science. It's a human story of curiosity and perseverance. These two small spacecraft have traveled farther than anything we've ever made. They are our senses reaching into the unknown. Each carries a golden record, a time capsule of Earth's sounds, music, and images. Greetings in 55 languages, music from Bach to Chuck Berry, images of our world. The record is a message in a bottle, meant for any who might find it. The odds of discovery are tiny, but that's not the point. The true audience was us. Creating it made us reflect on who we are. The record is a symbol of hope and optimism. The Voyagers will go silent around 2030, but their journey will continue for millions of years. They will drift through the galaxy, silent ambassadors from a small blue world. They are humanity's first true starships, carrying our story into the cosmos. Even when their voices fade, their legacy endures. They remind us that even a species confined to one planet can reach for the stars. The story of Voyager is the story of us. It's a story worth telling, and it's far from over. Our journey into the universe has only just begun, and Voyager leads the way.